Hello and welcome to Maths by Anuj.
So we have the question here, solution of the inequation fractional part of x minus 1, fractional part of x plus 2 greater than equal to 0, where this sign represents fractional part function. The options are x belongs to minus 2 to 1, b x belongs to I is integer, x belongs to 0 to 1 and x belongs to minus 2 to 0. So we have the inequation to be fractional part of x into fractional part of x minus 1 into fractional part of x plus 2 greater than equal to 0. Okay, so I can proceed with taking fractional part of x to be any variable like t, or I can simply proceed with the fractional part of x also. So here I see this fractional part of x can be written as fractional part of x minus 0, and this one fractional part of x minus 1, and this one to be fractional part of x plus 2 greater than equal to 0. So I see this inequation is already factorized. All I have to draw is the critical points on the number line. So I'll draw the critical points on the number line, that is minus 2, 0 and 1, using the wave curve method, plus minus plus minus. So the fractional part of x belongs to minus 2 to 0 union 1 to infinity. But as we know that fractional part of x belongs to 0 to 1, 0 to 1, and the fractional part range which we are getting from the equation is minus 2 to 0 union 1 to infinity. So it is not possible that fractional part of x can take any values in this range or in this range. So what is the common value that I can see in both? That is fractional part of x is equal to 0. So the only value of fractional part of x which will satisfy the inequation is 0. So as we know that x is equal to greatest integer of x plus fractional part of x, and if fractional part of x is equal to 0, this means that x is equal to greatest integer x, that is x will be an integer. Hence this is true for all the cases. Whenever fractional part of x is equal to 0, x will be an integer. Okay, so this is a condition that we should remember, that fractional part of x, if it is 0, then x is equal to greatest integer of x, that is x is an integer. Hence I can say that x belongs to integer. So the correct option is B. So the next question we have, let fx comma gx be two real valued functions, then the function hx is equal to 2 max fx minus gx comma 0 is a fx minus gx minus mod gx minus fx, b fx plus gx minus mod of gx minus fx, c fx minus gx plus mod of gx minus fx, d fx plus gx plus mod of gx minus fx. So we have with us hx is equal to 2 times max fx minus gx comma 0. So hx can be written as hx is equal to max fx minus gx comma 0 plus max fx minus gx comma 0. So now we can see that I will draw the graph for fx and gx. So this can be increasing graph fx, let us take, and gx, this is fx, and gx can be graph like this, gx. So fx minus gx will be like this, or it can be increasing graph like this. So in this range, in the in the range above x-axis. The maximum part is here, it is fx minus gx. For this part it is gx minus fx. Now I have to take the maximum of this function, so this here it is 0, so hx is equal to fx minus gx plus this part is negative, so I have to take mod for this, so it will be gx minus fx mod. So hx can be written as fx minus gx plus mod of gx minus fx. So that means option C is correct. Next question we have with us is, let r is equal to 1 comma 3 4 comma 2 2 comma 4 2 comma 3 and 3 comma 1 be a relation on the set A is equal to 1 2 3 4. The relation R is a function, B reflexive, C not symmetric, and D transitive. So now we have to check which of the following option here is correct. Here R is equal to what? Let me write here. R is equal to 1 comma 3 comma 4 comma 2 comma 2 comma 4 comma 2 comma 3 comma 3 comma 1. Clearly the function, clearly R is not a function, because as I can see 2 is being paired with 2 elements. 2 here, 2 is paired with 4 as well as 2 is paired with 3. So function R is not a function. R is not a function. Hence the option A is not correct. Now we check for reflexive. A relation R is said to be reflexive if only A comma A belongs to R. Okay, and in this I cannot see any such situation like that. Hence it is not reflexive relation. Not reflexive. Now for transitive, we have A comma B belongs to R if A comma B belongs to R and B comma C belongs to R, then A comma C must belong to R. Then only the relation R will be transitive. So here I can see that none of that condition is satisfied. Like 2 comma 3 belongs to R and 3 comma 1 belongs to R, but 2 comma 1 does not belongs to R. There is no 2 comma 1 belongs to R. So this is not transitive. It cannot be transitive. Hence the option D is also ruled out, B is also ruled out, and A is not correct. Now I have to check whether it is symmetric or not. So 1 comma 3 belongs to R and 3 comma 1 belongs to R. Okay, so and 4 comma 2 belongs to R here and 2 comma 4 belongs to R. But 2 comma 3 belongs to R, but 3 comma 2 does not belong to R. 3 comma 2 is not present in R, does not belong to R. Hence this makes this relation to be not symmetric. If 2 comma 3 comma 2 was in R, then it would have been symmetric, but since it is not, so it is not symmetric. So the option correct is C. The next question we have, the true set of values of k for which sine inverse 1 upon 1 plus sine square x is equal to k pi by 6 may have a solution. The options are A 1 by 4 to 1 by 2, B 1 to 3, C 1 by 6 to 1 by 2, and D 2 to 4. So we know that sine square x sin square x belongs to 0 to 1. So 1 plus sin square x belongs to 1 to 2. Now taking reciprocal, so 1 upon 1 plus sin square x belongs to 1 by 2 to 1. The reciprocal of 1 is 1 only. So now we have to take sine inverse of this. So sine inverse 1 upon 1 plus sine square x, this will belong to sine inverse of 1 by 2, that is from pi by 6 to pi by 2. Because sine inverse 1 is pi by 2. So now we have on the right hand side k pi by 6. Okay, so it means that k pi by 6 belongs to pi by 6 to pi by 2. Hence k belongs to 1 to 3. If k is 1, then it will be pi by 6. At k is equal to 3, it will be 3 pi by 6, which is equal to pi by 6 to pi by 2. Hence k is from 1 to 3. So the correct option is. Next question we have, a real valued function fx satisfies the functional equation f of x minus y is equal to fx into fy minus f of a minus x into f of a plus y, where a is given constant and f of 0 is 1. F of 2a minus x is equal to option A minus fx, B fx, C fa plus f of a minus x, and D f of minus x. So we have f of x minus y is equal to f of x into f of y minus f of a minus x plus f of a plus y. Now here we put x is equal to y is equal to 0. So this becomes f of 0 is equal to f of 0 into f of 0 minus f of a into f of a. Now f of 0 is given to be 1. So this becomes 1 is equal to 1 minus f of a whole square. This implies that 1 here, sorry, 1 this one and this one gets cancelled out. So f of a is equal to 0. Okay. Now we put x is equal to a and y is equal to x minus a. So it becomes f of a minus x minus a is equal to f of a into f of x minus a minus f of a minus a into f of a plus x minus a. So this becomes f of 2a minus x, and f of a is 0, so this part becomes 0, so equal to 0, and this becomes f of a minus a is 0, f of 0, and this becomes f of x, because a here and a here gets cancelled out. So f of 2a minus x becomes f of 1 is 0, so this becomes minus f of x. Hence option A is